The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and take a look at section 10.4. And it might be a little confusing on your schedule because it doesn't say 10.4 part 1 and then 10.4 part 2, but that's kind of what's going to happen. Basically, there's just one assignment, but we're going to take 2 days on it, okay? So there's 2 different ways to accomplish graphing parabolas, which is what we're going to be talking about. Today we'll cover one method, tomorrow we'll cover another. But the whole assignment, you've got 2 days to work on it, okay? All right, so what I want to do now is I want to switch boards to the graphing board. Give me a second here for this to load. And I want, let's see, which one do I want? I want 218. Oh, I want to get rid of that. Open this. Okay. So can you see a graph on your, or a screen where up in the left corner it says f of x equals x squared?
Yes.
Okay, so what we're going to be looking at today and tomorrow is graphing second degree equations. So these are not going to be linear equations. They won't be straight lines. They'll actually be what is called a parabola. And as we're going to see, it kind of has a U shape that either opens upwards or downwards. And we're going to start off with just a very basic one, which is f of x equals x squared. I'm going to go ahead and calculate values, put them in the table, and then plot them, and we'll take a look and see what we get there, all right? So I've already predetermined the x values I'm going to use from -3 to +3. And if I haven't said this in the past, whenever I'm graphing something new that maybe I'm not sure what it's going to look like, I always start with -3 to +3, calculate those points, and then take it from there. All right. So f of -3 would be -3, the quantity squared, so we get a +9, because the negative is inside the parentheses, so it's part of the base. Are we okay with that value?
Yes.
Okay. F of -2 is going to be -2 squared, which is a +4. F of -1 is going to be -1, the quantity squared, which is a +1. F of 0 is going to be 0 squared, which is 0. F of 1 is 1 squared, which is 1. F of 2 is 2 squared, which is 4. And f of 3 is 3 squared, which is 9. All right. Let's plot these points. -3, 9 is right there. -2, 4, right there. -1, 1 is right there. 0, 0 is right there. 1, 1 is right there. 2, 4, and finally 3, 9. Now, either I messed up big time with my calculations or it's not a straight line. And as I said, it's not a straight line. It's kind of a smooth curve. So don't take a ruler or straight edge and make straight lines between each dot. It's kind of a curved line that looks like that, okay? I didn't make a great job of it over on the left side, but you kind of get an idea. That's called a parabola. All right? Any questions about what I just did? I want to point out some things. First of all, this parabola, we would say that it opens upwards. So it looks like this. A parabola that looks like this, we say that it opens downwards, okay? And we'll talk more about that. For a parabola that opens upwards, this lowest point, which in this case is at the origin, is called the vertex. So for this problem, the vertex is at 0, 0 for the origin. Okay. Notice that there is some symmetry. When x is -3 and x is +3, you get the same y values. When x is -2 and x is +2, you get the same y values. When x is -1, when x is +1, you get the same y values. Now, yes, this is a function. You can have two different x's going to the same y, and it's a function. You can't have one x going to two different y's. That's not a function. So this is a function. It passes the vertical line test, etc. Now, because of this symmetry, notice, let me change colors here. On what in this case is the y-axis, we have what is called the axis of symmetry. In other words, about that line, which in this case is the y-axis, if we go here and here, we see that it's symmetric, here and here, here and here, it's symmetric, okay? The equation of the axis of symmetry in this case is x equals 0. Recall from the past that x equals 0 is the equation of a vertical line. This happens to be the y-axis, but the equation of the axis of symmetry would be x equals 0. All right. Any questions about what has happened so far? All right, we're going to look at a lot more graphs. Here on the left, I have the same graph that I just made on the previous page, okay? And I'm going to say that this graph is in the form of y equals ax squared. For this particular graph, a would be an implied 1. Likewise, here, a is an implied 1. All right? Now, continuing to use my x values of -3 to +3, I'm going to take a look at the graph of g of x equals 2x squared. So now my leading coefficient, instead of being a 1, is a 2, but it's still in the form of y equals ax squared. All right? Now, I've pre-calculated all the values, and then I've gone ahead and graphed. This graph, I didn't graph the -318 and the +318 because it went off the graph, but graphing these values, I almost made it there. Let's see here. Anyway, graphing, there we go. These values, I got this picture, okay? Now, notice A is positive, it's a 2. This graph still opens upwards. Also notice that the vertex is still at the origin and the axis of symmetry is still at x equals 0, the y-axis. So all those characteristics are the same as the f of x equals x squared, except that my y values have all doubled, haven't they? Look at the relationship between these y values and that y value, this y value and that y value. Because we've got a 2 in front, all the y values double, so the thing climbs faster, steeper. Do you follow that?
Yes.
That's making sense. All right. Let's take a look at h of x equals 1/3 x squared. Again, I've used -3 to +3. Again, it's in the form of y equals ax squared. Okay. But now a is smaller than 1. The graph still opens upward, still has the vertex at the origin, still has the axis of symmetry at x equals 0, but it opens, it climbs slower and opens up wider, okay? So for this, if A is larger than 1, it climbs faster. If A is between 0 and 1, it climbs slower, but it still opens upwards in all cases. Any questions about that? All right, let's go to the next page. Now, I've got f of x equals x squared again. Now, my a value is negative. Look what happened to the parabola. The y values here are the opposite of the y values there. Why is that so? Because order of operations, you would do the square first and then apply the negative sign. So I get y values that are negatives. My parabola opens downwards. Again, because the a, the coefficient of x squared, is negative. I still have a vertex at the origin, and it still goes through the y-axis as the axis of symmetry. All right? So if a is positive, the parabola opens upwards. If a is negative, the parabola opens downwards. All right? Any questions there? Going on. Now we're going to start with f of x equals x squared, or y equals x squared again. But instead of changing a, that coefficient out front, we're going to add a constant term. So it's going to look like this. It's going to be in the form of y equals x squared plus k. Think of k as a constant, even though the word constant starts with a c. I didn't make up these variables. I would have used a c. But anyway, all right. So x squared plus 2. Well, order of operations, what would you do first? You do the square, which would give you the same results as this, but then you'd add 2, which means these values are 2 more than those values. What does that do to the parabola? It moves it upwards 2 units. Do you see how the red graph is 2 units higher than the black graph? Do you see that okay?
Yes.
Then let's look at the blue graph. H of x equals x squared minus 3. What does that do? It takes the black graph, f of x equals x squared, and it moves it down 3 units. So the pattern is that whatever constant is out here, if it's a positive number, it moves the graph upwards that many units. If it's a negative number, it moves the graph downwards that many units. Okay. Any questions about that?
No.
Let's go to the next page. Now I'm going back to f of x equals x squared. I'm going to add a number, but it's going to be inside the square, okay? And the form is going to be this. So y equals the quantity x minus h, the quantity squared, okay? Look what happens when I put a 2 in the place of h. So x minus 2, the red graph is shifted 2 units to the right of the black graph. So x minus 2 goes 2 units to the right. Take a look at the blue graph. H of x equals x plus 1, the quantity squared. When it's a plus 1, it moves it 1 unit to the left. So the blue graph is 1 unit to the left of the black graph. Okay, are you seeing that? Antonia?
Yeah. Sorry,
okay, just
I was just writing it.
Wasn't sure if you were still alive. That's good. Okay, let me know when you're
I am alive. I'm getting confused, but I'm alive. No, I'm just kidding. I got it.
You got it? Okay, all right.
Yeah, thank you.
Now, let's put all the pieces together. But first, let's go back and review. The first thing we did was just graph f of x equals x squared. We got this parabola that opens upwards. Vertex was at the origin. Axis of symmetry was right there down the middle of it. Notice the axis of symmetry goes right through the vertex. Okay. Then we looked at if we change the a, the coefficient in front of the x squared, if it's positive, but it's larger than 1, the thing opens steeper, faster. If it's between 0 and 1, it opens wider, slower, but it still opens upwards. If a is negative, it opens downwards. If we leave the first term as x squared and we add a constant, a +2, it moves the graph upwards. A -3, it moves it downwards. So it does what you would expect, okay? A +2 moves up 2, a -3 moves down 3. Then we went inside, but here a -2 moved it in a plus direction. A +1 moved it in a minus direction. So inside it did the inverse of what you'd expect. And then we put it all together. So right here, this is the formula for parabolas that are of this type, okay? The following information is true about a problem, a graph, an equation, whatever, that is of this type, okay? If A is positive, the parabola is going to open upwards. So we'll say A greater than 0, parabola opens upwards. If A is less than 0, the parabola opens downwards. All right? Inside, if we have minus some number, so -3, so then H is 3, it moves to the right. If we have plus something, plus a number, it moves to the left. So it kind of does the inverse of what's going on inside. If K is positive, it moves upward. If K is negative, it moves downward. So here it does what is obvious. So what I like to say is inside inverse, outside obvious. And we'll talk about that. All right, now, let's look at our equation, which is a function. All right, A is 1/2. So this parabola opens upward because A equals 1/2. So it's this case. All right. Now, again, I want to go back. Notice here, the vertex is still at the origin. The vertex is still at the origin. Vertex is still at the origin. But here, when we shift the whole thing up 2 units, where's the vertex now? It's at, here it would be at what, 0, 2, and here it would be at 0, -3. Okay. What about here? Where's the vertex? It's at 2, 0, and it's at -1, 0. The following is true. The vertex of a parabola in the form y equals a times x minus h squared plus k, the vertex is at h, k. So what is HK? Now you've got to be careful. This is a little tricky. The form is X minus H. So if we took X plus 2 and we wrote it as X minus H, H would be -2. Or you could just say it's the inverse of what's inside there. So the vertex is going to be at -2, and then the K value is -3. Okay. So the vertex is at -2, -3. How are you doing? This is where people usually get confused because of the X minus H.
Yes, that's where I'm lost.
So this would be like X minus -2. How could we write X plus 2 as X minus something? It would be X minus -2. So H is -2. Or you could say the X value of the vertex is going to be the inverse of that number. Okay. You all right with that?
Yes.
All right. Now, the axis of symmetry, which I'm just going to abbreviate AOS, is at X equals H. Now, remember, this is HK, so it would be X equals -2. And that's not the actual parabola. It's just the axis of symmetry of the parabola. So it tells us that the parabola is going to be symmetric about that dotted line. I wrote, or a dashed line. I wrote it that way because it's not actually part of the graph. It's a dotted line to help us with the structure of the graph. But the vertex is at -2, -3. The parabola opens upwards, and the axis of symmetry is at X equals -2. All right? I know I'm dumping a lot on you here.
Yes.
Now, I'd already pre-made my table, but if I hadn't, what I would want to do is after I'd found the vertex, I would put that at the center of my table, and then I'm going to go 3 units to the left and 3 units to the right. So I would have started with -2, and then I would have put in -3, 4, 5, -1, 0, and 1. Okay? You all right with that?
Yes.
All right, what I'm going to do now, I'm going to erase all this stuff because I need some room to do my calculations. So G of -5 is 1/2 times -5 plus 2, the quantity squared, minus 3. Okay? Which is 1/2 times -3 squared minus 3. Which is 1/2 times 9 minus 3, which is 9/2 minus 3. Which is 9/2 minus, my common denominator is a 2. I'm going to multiply the 3 by 2/2, so I get 6. So 9/2 minus 3 becomes 9/2 minus 6/2, which would be 3/2. Okay? Are you all right with that?
Yes.
Okay. Going on. Next point. G of -4 is 1/2 times the quantity -4 + 2 squared minus 3, which is 1/2 times -2, that is -4 + 2 is -2, the quantity squared, minus 3, which is 1/2 times -2, the quantity squared is 4, minus 3. 1/2 times 4 is 2. 2 minus 3 is -1. All right.
I have a question.
Yes.
On the G times -4 equals -4. So how you got the half? I know how is the formula that we're using, right? We're just replacing it.
Yes, we're using this formula,
Mm-hmm.
but we're putting the X value right there.
Oh, got it. Okay, perfect. Thank you.
Yeah. Are we good with these first two values?
Yes.
Okay, I'm going to erase them because I need room again. And now let's find G of -3, which is 1/2 times -3 + 2 squared minus 3, which is 1/2 times -1 squared minus 3. That is -3 + 2, which is 1/2 times -1, the quantity squared would be +1 minus 3. So this is 1/2 minus 3, which would be 1/2 minus, let's see here, we'll multiply by 2/2. So 1/2 minus 6/2, which is -5/2. Okay.
Got it.
All right. Let's find G of -1. So that's 1/2 times -1 + 2, the quantity squared, minus 3, which is 1/2 times -2 plus, or -1 + 2 is 1, so 1 squared minus 3, which is slow down here, which is 1/2 times 1 squared is just 1, and 1/2 times 1 is 1/2, so we've got 1/2 minus 3, which is 1/2 minus what? Well, let's see here. That's going to be over 1. We're going to multiply by 2/2. We're going to get -5/2. Okay.
Yes.
Oh, look, these two values match. As well they should, because they're equidistant from the vertex, right? Mm-hmm. So what do you think, what's this value going to be?
It's going to be -1.
Excellent. And this one?
That one is going to be 3/2.
Correct. Okay, so now let's graph these points. -5 3/2, which is -5 1.5, so that's right there. -4 -1 is right there. -3 -5/2, which is -2.5, is right there. -2 -3, I've already got that. -1 -5/2 is right there. 0 -1 is right there, and 1 3/2 is right there. And so we get this parabola. Okay.
Got it.
A is 1/2, which is positive. So the parabola opens upwards. The vertex is at HK, -2 -3. The axis of symmetry is at x equals -2. All right? We doing okay there?
Yes.
All right. Let's do one more of these, and then we're going to go look in WebAssign and talk about how you graph in WebAssign. Okay? All right. So, let's see here. Looking at g of x and using that the vertex is at hk, can you see that the vertex is at 3, 2, x minus h plus k? You see that?
Yes. Yes.
So the vertex is at 3, 2. A is a -1. So this parabola is going to open downwards. All right?
Yes.
Okay. Now, let's find g of 0. So I'm going to use this formula and put in the x values to find the corresponding y values. Negative, the quantity 0 minus 3 squared plus 2, which is negative. 0 minus 3 is -3 squared plus 2. -3, the quantity squared is 9, so that negative sign outside, it hits at -9 plus 2, which is -7. We good with that?
Yes.
All right. Let's find g of 1. So that's negative times the quantity 1 minus 3 squared plus 2, which is negative. 1 minus 3 is -2 the quantity squared plus 2, which is negative times, -2 times -2 is 4, but now the negative sign outside hits it, so -4 plus 2, which is -2. We good to go?
Got it.
Okay,
Yes.
let's find g of 2. That's negative times 2 minus 3 squared plus 2, which is negative times -1 squared plus 2, which is negative times 1. -1 squared would be 1, so we get negative times 1 plus 2, -1 plus 2, which is 1.
Got it. Thank you.
Right. Now, let's find g of 4. What do you think g of 4 is going to be? I don't want you to calculate it. Just tell me what you think it's going to be.
I'm thinking it's -7.
No.
No.
That's going to go with this one.
Oh, yes, you're right. It's going to 1.
Right. And what's this next one going to be?
That would be a 2. No.
A what?
A -2.
And the next one?
That's the -7.
Okay, well, let's just go with it. Save us a little calculations. 0, -7, 1, -2, 3, 3, 2. Oh, 2, 1, I forgot that one. 2, 1, 4, 1, 5, -2, 6, -7. Oops. I've got a parabola. It opens downwards because A is negative. The vertex is at HK. which is 3, 2. And the axis of symmetry is at x equals h, which would be x equals 3. Okay?
Yes.
All right. Now we're going to go to WebAssign. So give me a minute here. And I'm going to close up this screen. Let's see. 4. Come on. All right, here we go. Okay. Sorry, this is taking so long, but to switch things around takes a bit. I should have some lovely music playing or something while I'm doing this. Okay. All right. So now you should see WebAssign on the left and my whiteboard screen on the right.
Yes.
Okay. So let's take a look at, let's see here. Let's look at number 2. It says the lowest point in the graph, 2, -1. This is called the blank of the parabola. What would that be? What's this point called? It's the vertex. Okay?
Okay.
If a parabola opens downwards, the high point would be the vertex. So what is the vertex here? It would be what? 2, 1? Does that make sense?
Yeah.
Okay.
You said if it goes down, the high point is the when
vertex.
it goes down is okay.
Yeah, when it opens downwards, the highest point is the vertex. When it opens upwards, the lowest point is the vertex.
Oh, okay.
All right. What I want to look at here. Let's see here. Let's take a look at problem number 12. Okay.
Okay.
And I'm going to kind of jump around a bit here, depending on how much time we have and everything. But it says, find the vertex and the axis of symmetry of the graph of the function. And it says, hang on, I got to click on here. F of x equals x minus 1 squared plus 6. So A is 1, H is 1, and K is 6. Because if we think of this as x or A times x minus H squared plus K, so the implied one, A is 1, H is 1, and K is 6. Are you following that?
Yes.
So the vertex is at HK. So that would be at 1, 6. So over here, I'm going to put in 1, comma, space, 6. Does that make sense?
Yes.
Now, the axis of symmetry is at x equals 8. So that would be x equals 1. This is one of the most missed problems every quarter. The axis of symmetry is an equation, and it has to be written in the form x equals. I'm gonna just put in 1, and we'll see what happens in just a minute. All right, A is 1. So the parabola opens upwards or downwards?
Up.
Okay. So let's see what it says. Oh, it says that's wrong. What's wrong with it? It has to be x equals the number. Okay. And I can almost guarantee you that half the people will miss that problem or problems like that on the test because they forget. So axis of symmetry is an equation of a vertical line, x equals some number. All right.
Yes.
Let's take a look at 13. What is h for this problem? Be careful. What is h? Inside, inverse, outside, obvious. What is h? How would you write x plus 3 as x minus, what would it be? X minus what? Oops. -3. Okay. Again, x plus 3 inside inverse. So the inverse of that number goes there. And then the y value is what's obvious outside goes there. Okay.
Yes, got it.
Axis of symmetry is going to be x equals h. What's h in this case? It's always the x value of the vertex.
3.
Is that a 3 right there?
-3.
There you go. Watch your signs.
I have a question.
Yeah.
So if it's a negative outside, do I distribute the negative or
No, you're not distributing anything.
Okay, got it. Okay.
Okay.
Makes
Does this thing open up or down? What's A? Positive
it goes
or negative?
down.
It opens
Negative.
downward, right. Okay, good. All right, now, this is super important, how to graph in WebAssign, all right? So the vertex is going to be at 3, 7, okay, HK. The axis of symmetry is at x equals 3, all right? You okay with that part? Now, if we were graphing in a classroom, not using online homework, you would have a piece of graph paper and you would make an X and a Y axis and there'd be a scale and let's see here. And I'd have you make a table and I'd have you put the vertex at the center of the table and then calculate some values and plot some points and then draw your graph, okay? That's if we were doing it by hand. In WebAssign, it's a little bit different. In WebAssign, you've got to do the following, and this is one of those things that aggravates me because every quarter, people that don't watch this video and try and figure it out, good luck. I didn't figure it out. I had to ask my colleagues because it's tricky. What you've got to do, you have to plot 2 points. The first point has to be the vertex, okay? But here's what I'm going to do. I'm graphing a parabola, not a line, not a straight line, but a parabola. I'm going to click on that. I don't want this one. I want this one. So I click on it till it turns blue, okay? The next thing I'm going to do, I'm not going to click on this, just the parabola. I'm going to come over to the graph and I'm going to plot the point 3, 7. Now notice my scale, it's each square is 2 units. So 3 is right there, 3, 7 is right there, okay? But I need a second point. So back over here, I've got the vertex from HK. I need to calculate one more point. So how about if we put in f of 4? Let's see what we get. 4 minus 3 squared plus 7, 1 squared plus 7, 1 plus 7, 8. So my second point is 4, 8. So 4, 8 is right there. And there's my parabola. So again, in WebAssign, you click on this, you click on the vertex and a second point, and then it will give you the graph of the parabola, okay? Any questions there?
No.
Now, let's say I've got a point that's tricky to plot, like it's 2 1/3 or something like that. Just like back in when we were graphing lines, you can click on the parabola, and here's the first point we put in, 3, 7. There's the vertex. Here's the second point, 4, 8. So if I graphed my point wrong, let's say somehow it ended up over there, I can come back here and I can correct it. Was it 4, 8? I can't remember what it was. Let's see here. Yeah, 4, 8. Okay. You following that?
Yes.
So you're going to use this thing, this button here, turn it blue, click on the vertex, then a second point. That will give you the correct graph. Now let me show you what happens if you if you don't follow the directions I just gave you. Okay. So let's, instead of doing the vertex first, let's do 4, 8 first, and then do 3, 7. Oh, it thinks that that point's the vertex. So instead of it giving me a graph opening up, it gives me a graph opening down, and that's wrong. So you've got to do it in the correct order. Okay?
Yes.
All right. So you should be able to work on not necessarily all of the problems in the assignment, but all the problems that have to do with that form that I've highlighted down there, the y equals a times x minus h, the quantity squared plus k. Tomorrow, we'll look at a different form as well as some application problems. All righty. So I'm going to go ahead and stop the recording.